time how long the injectors are open to spray pilot fuel into the engine. They control it through the measurement of kilogram per hour usage. So the fuel tank protection, we have different protection systems. Here another screenshot. We have the dry run, sorry, we have dry run limit. The dry run limit, it's the dry run limit here is on 80 millimeter. Can be, all the settings can be changed from my side or from Schnell side as well. That protect the high pressure common rail pump of running dry. So if the level goes underneath a certain level in the fuel pump unit tank, before we start to suck air into the system and that the common rail pump runs dry, we have this protection system what will stop with the arrow the CHP for running dry. Then we have the overfill limit. Overfill vessel, it's on 430 millimeter at this point. This protect that, yeah, actually we protect the environment of fuel leakage. And we have a maximum refilling time, 180 seconds. This is to protect, on one hand side, the environment. For example, if we have a leakage or a broken pipe after refilling pump, the pump will run and the level in the tank will not increase. That means the pump will run continuously and supply the fuel into the environment. To prevent that, we have a limit time that the pump must be stopped or the tank must be refilled within a time of 180 seconds. And we like to prevent a damage on the pump, refilling pump as well. If the refilling pump is running dry because we suck air out of the fuel tank because fuel tanks are empty, for example, to prevent to run the refilling pump dry, we stop after 180 seconds. If the pump is running dry, that means actually that get overheated and the pump get damaged. So we like to prevent that with this protection system. Some further protections. We have some warnings and deep in the software some stops as well. We have a warning arrow of fuel temperature. If the fuel temperature in some special cases get close to 0 degrees or below, the light oil start to change the viscosity of the liquid, and the common rail system cannot work with a viscous liquid as a fuel. So to prevent that, we have a temperature, and this gives a warning, only a warning, only to give the operator indicator that there is something wrong, or the petrol or the fuel is too cold. Then we have a warning arrow, fuel filter pressure limit. So we're talking about here that one. This is 20 bars. That's the indicator, what I mentioned already, that maybe the filter is clogged or must be replaced earlier. So this indicator that the pressure get over over a usual operating range, which could damage with overpressure the filter and so on as well. Okay, then we have the delay of refilling signal for fuel usage management. So this is 60 seconds. You have to understand, if we refill the tank, during the time of refilling the tank, we cannot measure the usage of fuel from the engine, because we're refilling in the same time we use fuel to the engine to keep engine running. So we cannot measure, because if it's refilling, we're filling up, that means actually we could have a negative use, because we are refilling more than we suck out. So the function of Schnell is that we stop the measurement during refilling. And you have to understand, if we refill the tank, the fuel goes into the tank and they have like waves or small bubbles or something in the tank. So it needs a little bit time to stabilize the liquid fuel in the level in the tank, that we have a stable level again before we start measuring the fuel consumption or the fuel usage in kilogram per hours again. So we need the stability, otherwise if the measurement fluctuates too strong, it will have a direct impact on the pulse width of injection of the injectors, and that could have a damage on the injectors. Okay, but we will go into that deeper. Don't worry. Okay, so the Commonwealth, the Commonwealth system as an overview quickly. Okay, we was talking about the fuel pump, refilling pump is underneath here. We filling the tank here. It's a weighting bin, so the fuel pump unit tank with the level sensor. From the level sensor goes up to the high pressure pump. The common rail high pressure pump is located here. Next to the high pressure pump on the left, we have the array of filters that filter all the fuel before it goes into the high pressure pump again. And from the high pressure pump, it goes up to the common rail, where it gets distributed to the separate injectors and cylinder heads of the engine. Let's jump to the next slide. Jump. Yep. Okay. Schnell common rail system. The advantage of the Schnell common rail system is that we can optimize the combustion process with the high pressure of the common rail system to get the extremely fine fuel sprayed in the combustion chamber. You remember my other video? We was talking about the millions of small sparks what ignite in the combustion chamber the biogas. That's exactly what we can do with a higher pressure, with a more time pressure. We can ignite the biogas much better. Through the design of the system, we can reduce emissions. Excuse me. And through the flexibility with the common rail system, we are totally free to select the injection time, the length, the position, when we start injection, how long we inject the fuel, and have the best control about the whole pilot fuel consumption, and we can have a big impact on the efficiency through the control of the best combustion, or the ideal combustion. We'll come to that later as well. Yeah, from the common rail system goes the fuel goes directly to the injectors. So that Schnell, sorry, I'm always talking about me. This is not me, it's Schnell. So Schnell use microsac type injectors, the special type injectors which usually used to inject a small volume with high quality, so with very fine spray. Injectors, electric magnetic actuated valves That means we can control it on microsecond exactly when we like to open the injectors to spray the pilot fuel or light oil into the combustion chamber to ignite the biogas. So the injectors have a special ramp-up pressure profile. So we have our standard pressure goes to the injectors to open the injectors with the magnetic valve, and then we get the nice ramp of spray into the combustion chamber. So the standard operation pressure is up to 1000 bars. In biogas, pilot fuel, so gas mode, we operate between, depends on different special application, between 250 and 600 bar. But the limitation, on the other hand, we have a limitation. We have a limitation out of the design of the micro suck type injectors to have this benefit, this advance of have a perfect spray of a small amount, because we are focusing to reduce the diesel consumption or the pilot fuel consumption as much as we can. So focus on the smaller limits to spray perfectly. Have the negative on the other side, that the injectors are not designed to spray a big amount of diesel or pilot fuel into the engine. So that's why we have the limitation on the other hand side. If you run only on diesel or light oil fuel operation, we have a limitation of maximum load. At this system, I think we're talking about 150 kilowatt. So the injectors cannot supply more diesel or light oil to operate on higher than 150 kilowatt. But the CHP is at 250 kilowatt. So that's a negative on that side. But the design of the CHP is not made to operate with 250 kilowatt in light oil or diesel mode. The design is to operate with a small amount of diesel or light oil injection in gas mode. So it's all about design of the system. So we get limitation on that side to understand that. Okay, now we jumping to the inlet air gas flow diagram. So I copy paste here one of a plant. That's from the visualization screenshot. We're talking about the gas flow and the airflow. First of all, because of the safety, we usually all the plants. I'm not 100% sure if this is a regulation in Japan and installed in Japan as well. But usually you need in the gas supply system very close actually to the gas storage or to the gas storage or to the gas pipes. In front of the gas blower, usually there must be a under pressure safety switch installed. This safety switch prevent, that's installed very close to the gas storage. This prevent actually that we get a too high under pressure in the gas storage, what can damage the gas storage or the digester, or suck if there is not enough gas supply, that we suck air, that means oxygen, into the gas storage. And if you suck oxygen into the gas storage, that means we get a higher oxygen content in the gas. And if you have a higher oxygen content in the gas, the gas is get more explosive or flammable. To prevent that, damage on the tanks, on the storage, and prevent that we suck oxygen, so air, into the gas, usually there must be an under pressure switch installed in the system. This under pressure switch is connected to the CHP, and if the underpressure reaches the level what is adjusted here on a negative pressure, it will stop the CHP with the message of low underpressure gas. Exactly. So to prevent damages and storage, digest the tank and the gas pipe system. After the gas supply system from the tank, sometimes we have a main gas blower in front of the CHP, a centralized gas blower. Usually we use a gas pressure regulator. So the gas pressure regulator is a mechanical, is a mechanical spring regulator. It means there's like a membrane inside with a spring on top. Here on top there's the spring, there's a membrane inside, and over this regulator we can adjust the pressure. So the one thing, or the most important thing, is usually it's installed in front of the gas blower of Schnell. So if there is a center gas blower to provide gas to the CHPs, then we will have a pressure regulator close to the gas blower of the CHP, in front of the gas blower of the CHP, to keep the gas supply and the fluctuations stable. So the gas regulator, the main function is to keep the pressure of the gas stable in the gas pipe before it reaches the CHP. The gas fluctuation will have fluctuations or impact on the load fluctuation on the CHP. So to prevent load fluctuation, it's good to have a gas pressure installed. So gas pressure changes impacts could happen through other CHP on the same gas pipe. So for example, we're operating two CHP on the same gas pipe. So the volume of gas flow is as much as both CHP use. So now you have to understand what happens if one switch off with arrow. Immediately 50% of the gas flow is not used anymore, but the flow is still there. So that means the other CHP will get a pressure peak and will rise the load, or get a peak of the load as well, until we can regulate the gas supply back to usual. And to prevent that, the gas pressure regulator can compensate these fluctuations. As well, on the gas storage, if the pre-pressure change on the gas storage, we can get fluctuations on the gas pressure which will have direct impact on the load again. As well, as far as I know, you don't working with open gas storage, what is connected to the environment. There are designs out that you have like a gas storage on top of the digester, looks like a balloon, like a rubber balloon. If you have wind and this cover get pressed from the wind, that will have impact on the gas pressure as well, which could have impact on the engine load again. Okay. Yeah, then after the gas regulator, actually here that's a design standard from Schnell that's called GAM. It's actually gas treatment system. You use your own gas treatment system, so we will not talk about that point. But after the pressure regulator, we run into the gas blower. So the gas blower, we have the gas blower, usually with two manual measurement tools to measure the pressure in front and after, so that we have an indicator and can compare it with the operation of the gas blower. So the gas blower function first is to compress the gas. or supply the gas, that we get enough gas supplied to the CHP what is needed to operate on the target load. So we need the sufficient volume of gas supplied to run on the target load. The gas blower is controlled via or by a frequency converter, and the frequency converter is connected to the CHP PLC and is speed controlled. That means we're controlling the speed of the gas blower by the PLC. In your case, it's controlled. We have two options of controlling the load at the CHP in gas mode. One is controlling by gas blower, load control by gas blower. The other option is control by the gas actuator. In most of your cases, I think all the plants are controlled by the gas blower. So the gas actuator open, we come later again to that, open to a certain point, and it's a fixed point in percentage or in angle. And the load of the CHP, we have a target load of, for example, 250 kilowatt. So the load will be controlled via speed control of the gas blower. If we don't reach the load, the speed will increase until we reach the target load of the CHP. If we exceed the target load, the speed will be reduced to keep the load stable on target. So this is the standard function of our gas blower. After the gas blower, we have a gas filter. We like to make sure that we get clean gas, filtered gas into the gas train system. So we have here the housing with O-ring underneath. There's a cover, the O-ring is underneath. It's very important always that we make sure that O-ring is tight. If we check the filter as well here, the filter here is important that they have this small gap between the housing and the filter when you put it back in. The filter should not be lying exactly at the edge of the housing. Same on the cover, the filter actually is sitting underneath here, not underneath here. So for the filter is very important. When the filter standard basic should be replaced every 3,600 operating hours. But we have to check it if the filter gets wet or we get condensate into the filter and the filter get blocked through water and dirt, we have to maybe replace it earlier. If we not replace it early enough, then if, for example, if we have condensate or water or wetness in the gas, we will suck the water into the gas train, and the gas train they will have problems with high content of humidity or water that gets sucked into the system. So condensate, dirt, solid particles, we have to filter out with this filter. If it's always getting too dirty, too wet, this is an indicator that something in front of the system is not working properly, or we have too much condensate in the gas pipe or so on. So take care about that we focusing on the gas filter. If the gas filter is always dry and clean, we are on the safe side that we're not damaging any part or equipment after the gas filter